be presenting the Linux file system and security. We will be starting off with the history, which Linux was developed in the early 90s by Finnish engineer Linus Torvalds. At the time, Torvalds was a computer science student at the University of Helsinki in Finland and began working on the Linux project as a personal endeavor. He released Linux as a free software for anyone who wanted to use it. Now, what is Linux file systems? Linux file systems is also known as file systems are the methods and data structures used by Linux operating systems to manage and organize data on storage devices such as hard drives and SSDs. So pretty much any type of system that is used to separate out your folders and to put different files on different folders and places on your computer. The Linux operating system, known for its stability, flexibility, and security, relies on a robust file system to manage data and maintain the integrity of the system. Linux file systems, commonly referred to as extended file systems, have evolved over the years to meet the demands of modern computing. The system is also supported on every major computer platform. Linux supports various file systems such as ext4, CFS, XFS, and so on. On a Linux system, every file is owned by a user and a group user. Initially, a file's owner is identified by the user ID of the person who created the file. The owner of the file determines who may read, write, modify, or execute the file. Ownership can be changed with the chown command. Every user ID is assigned to a group with a unique group ID. Now, here are two major suppliers, SUSE and Red Hat Enterprise. There are multiple types of commercially backed Linux distributions. And here are some of the examples that I have put, like Red Hat, SUSE. There are a couple other ones like Debian, Slackware, and Arch Linux. Red Hat Enterprise Linux provides more than an operating system. It also connects you to Red Hat's extensive hardware, software, and cloud partner ecosystem, and it comes with 24/7 support. SUSE Linux Enterprise Server is a modular Linux distribution for both multi-module and traditional IT. There are a lot more, but these are just two that I have found to be interesting. Now, here are some of the features of Linux file systems. A couple that I have wrote down on here is the file system organization data into files and directories, allowing for hierarchically organization of data. And directories are used to group related files. Linux file systems support file permissions, including read, write, and execute permissions for the owner, group, and others. This is a fundamental aspect of security. Some file systems support ASLs, which allow for more fine-grained control over file and directory permissions, enabling users to define access for specific users or groups. Another one is Linux file systems implement a robust permission system to control access to files and directories. Another feature would be journaling, which most Linux file systems use journaling to improve reliability and recovery after a system crash. Also, another one would be extensibility, where they support dynamic resizing, allowing you to expand or shrink file systems on the fly. And like we had spoke about the ACLs provide the fine-grained control. Then there's also defragmentation, where some file systems like ext4 include tools for online defragmentation to optimize disk space usage. So these are just a couple of features that they have. Then we're going to speak about the feature matrix, where the matrices are a two-dimensional set of numbers or symbols distributed in a rectangular shape. in vertical and horizontal lines so that their elements are arranged in rows and columns. Well, in context of Linux file systems and security, a matrix typically refers to ACLs, which are sometimes informally referred to as permission matrices. ACLs extend the traditional Unix file permissions systems by allowing you to define more granular and fine-tuned access controls for files and directories. An ACL is a list of permissions associated with an object that specifies which users or systems processes are granted access to and what operations that they can perform. Now, ACLs provide a more flexible and comprehensive way to manage access to files and directories compared to the basic Unix file permission system. ACLs are also used to control access files and directories by specifying permissions for individual users and groups. This means you can grant specific users or groups permissions to read, write, and execute or perform other actions on a particular file or directory. Now, for example, you can grant access to user A, write access to user B, and execute access to a specific group C on a particular file. Now, the main advantage of using ACLs is the increased granularity and flexibility in controlling access. They allow system administrators to define and manage access permissions in a more detailed manner, making it easier to implement complex security policies while avoiding the need to create numerous groups. All right, now we're going to move on. Now, it's a comparison with other products. Similar products. I put down the Windows NTFS and macOS HFS, where the strength is that the NTFS offers features like bi-level encryption access controls, so pretty much like support for larger file systems. But the weakness is that NTFS is not native to Linux, and while there are third-party drivers and utilities for Linux to work with NTFS, native support is still very limited. NTFS is also not as robust in terms of data integrity and performances as some Linux file systems are, like ext4. Now, the strength of the macOS is it offers good integration with macOS, providing features like journaling, encryption, and snapshot support. But it is mainly meant for Mac hardware, so that does kind of put a limitation on it. And the weaknesses is that these file systems are not natively supported by Linux, just like the Windows, which can limit a lot of flexibility. It is also considered outdated, while APFS is designed primarily for Apple devices. So it does make things a little difficult when you can't use it on other hardwares. So it isn't as useful. Another one that I could give an example of is cloud storage services, where the strengths are that the cloud storage services offer scalable remote storage with high availability and disaster recovery options. They typically provide strong security features, encryption, and so on across multiple devices, but the weakness is that cloud storage services may have ongoing costs, data privacy and control can be big concerns, and they may not be suitable for situations where you need to complete control over your file system or have limited internet access or connectivity. In summary, Linux file systems like ext4 and BTRFS are optimized for Linux-based systems and are well integrated into the Linux kernel. They provide strong data integrity and performance. However, their compatibility with other operating systems may be limited. And other file systems and storage solutions have their own strengths and weaknesses. And the choices should be based on specific use cases and requirements and performance considerations. Now, to sum everything up, how computer forensics and the Linux file systems connect with each other. Well, Linux file system and computer forensics are closely tied together, as computer forensic involves the process of collecting, preserving, analyzing, and presenting digital evidence from computing systems and storage devices, including those running the Linux operating system. So pretty much it connects by just, here are just some of the different ways. Data recovery, well, in computer forensics, data recovery is a critical step. Linux file systems determines how data is stored and organized on storage devices. Understanding the specific file system used on Linux system is essential for recovering deleted or damaged files and for extracting evidence. Then there is data analysis, where forensic investigators need to analyze data on Linux systems, which involves examining file structures, metadata, timestamps, and file content. Knowledge of the Linux file systems is crucial to interpret this information correctly. Then the chain of custody is maintaining a proper chain of custody is a fundamental aspect of computer science. This includes documenting the handling and storage of digital evidence, which often involves preserving the integrity of the file system and metadata during the investigation. Now, the recovery of hidden data, Linux file systems may contain hidden or deleted data that can be critical in forensic investigation. Understanding how these file systems store and manage data is vital for uncovering hidden or deleted information. File timestamps. Linux file systems maintain various timestamps, including access, modification, and creation times. These timestamps can be crucial in determining when files were last accessed or modified, helping investigators establish a timeline of events. That was one I had just added on. And then the forensic tools and techniques for analyzing Linux systems often rely on a thorough understanding of the file systems. Specialized forensic software may be used to acquire disk images and analyze the file system structures. So computer forensics and Linux file systems are crucial and super beneficial to each other. They're both needed. We need computer forensics to be there to put everything in the right perspective and to be able to recognize any type of malicious events trying to be done throughout the systems. And thank you for listening to my slideshow, and I hope you enjoy.